This is called a rapid response to a national crisis. This was a team effort between our research group and Boehringer Ingelheim Animal Health. Can't thank BI enough for the support they gave us during the study, but you'll see why we call it a rapid response in a minute. Well, the situation, looks back at, say, Expo time, from our perspective, was this virus had emerged. Caesar did a nice job of showing the story behind this virus, but the industry was really in a panic mode. And there were some observations from the field that this is the worst strain of PRRS we've ever had. Vaccines don't work anymore, biosecurity protocols don't work. And we were seeing some interesting things like summer infections in regions of low density. But what worried us at Pipestone was people were giving up. There was a defeatist attitude in the industry, and that's not normal for pork producers and swine veterinarians. We're usually quite the opposite. So we needed some action. So we have a really fantastic chief veterinary officer. His name is Dr. Joel Neerum. You might know him. He basically said, hey, we need some help here. We need some answers. Can we do a study and get some data on this thing? Is it really as bad as what everybody's saying? So I went to work with our statisticians and our director of research operations, Roy and Dan, respectively. And we basically designed a study in about a 2-month period of time to fit into some space in our research barns between July and September. And so this was really ironic because our barns are never empty, but here we had some time. We had 4 rooms in our biosafety level 2. We had some space, and we had 2 weeks in one of our wean to finish research barns. And then we reached out and asked if Boehringer would join the team. Dr. Sponheim, Dr. Phillips, and Mr. Rusvold came on board, helped us with the study and the cost sharing because we didn't have time to write a grant. We were working in real time. And then we reached out to Dr. Monsi Tarimare and Dr. Corzo at the swine group at the U and said, gosh, is this something we could maybe present at the layman conference? So we basically set up our research questions on these field observations. And I'm going to go real high level on how we did this, and we can get more details if you like. But the first observation was this is the worst strain of PRRS virus ever. Well, let's see. Let's take PRRS virus 144 lineage 1C, which we recovered from one of our farms and sequenced it and looked at it to be sure it was exactly the right virus. Let's compare it to another virus we've worked a lot with in our research laboratory, the PRRS virus 174, which prior to the 144 emergence was considered the worst strain of PRRS ever. Let's give it to some pigs and see how they grow, how many die, what level of virus replication or load is in the pigs, do they get sick, what's their fever, how often do we have to treat them, etc. I'll show you those data in a minute. And then the other question, their observation was, well, vaccines don't work anymore. Well, let's see. Let's do a challenge study. Let's take 144 lineage 1C. Let's vaccinate some pigs with the Boehringer PRRS Engelvac MLV product or the Prevacent Elanco product. And let's challenge them with the 144 and see if the vaccine can do any good. And we'll compare that to a non-vaccinated control group. Finally, the third observation was biosecurity protocols are ineffective. So we did several small pilot studies that had very binary outcomes. Does the virus live? Yes, no. Can we prevent spread? Yes, no. And let's look at some very key or standard ways that this virus can potentially spread based on PRRS history. Can it go in the feed? Can you get it on your boots and your coveralls? Can you walk it around your farm? Do infected pigs generate aerosols? Does it live in slurry for longer than what's been published, 14 days, which is kind of the standard survival of the virus in slurry versus 21 days? Does it live longer, for example? And then let's see if the feed truck can be a vehicle for this virus to move around. And I'm going to explain that a little bit in a minute. But then also let's look at some prevention, some protocols, some products, feed mitigants. Let's test one called Guardian or the other one called Salcurb. Do these mitigants neutralize the virus in the feed? Do disinfectants that we use on farm, Ag Forte Pro or Synergize, neutralize the virus? Do filters work? Let's take some Camphil Farmer 14 filters and see whether they can stop the aerosol spread. Then finally, let's see if we've got contaminated boots and coveralls after dealing with infected pigs. What happens if we take a shower and change our clothes and boots? Does that work? So this feed transport model I alluded to a minute ago, let me explain this a little bit, because this was a behavior pattern we were noticing was happening in the summer, where producers were taking bean meal from the production facility to their mills, dumping it off and backhauling complete feed without any type of sanitation between those events. And so we set this up in a little model. We took a couple little toy trucks there and we filled them with soybean meal that had been spiked with the virus in the upper right-hand corner. And we let it sit in that little trailers for 1 hour. Then we emptied it out and we didn't clean them, but we put complete feed back into the trailers and let it sit for an hour, kind of like simulating driving the meal from the soybean plant to the mill, and then again driving back the complete feed to the farm. So back hauling, again with no intervention of sanitation. Then let's feed it to pigs and see what would happen there. Let's collect aerosols. Let's collect air in the rooms where we had these infected pigs housed, and that's what you see in the picture on the left. Up in the ceiling there, the little black object, that's a air collector that Dr. Dale Polson from Beringer brought to the table. Let's collect air in rooms where infected pigs are being housed. That's on the left. And then let's collect air on the outside of a fan after the air from that contaminated room has passed through a filter. Do those filters stop the virus from moving from the inside of the barn to the outside of the barn? Let's see what we learned. Okay, so let's get oriented here. This is the pathogenicity study. So that would be, this is the worst strain of PRRS virus ever question. And then the vaccine efficacy study, post-challenge. And so we're gonna infect pigs. We're gonna let the virus spread in the room. Some are gonna be vaccinated in one room, some not in another room. And let's see what happens. So on the left, we've got average daily gain, percent mortality, fever at day 14 post-infection, and the number of treatment events. And on the top, you see vaccine A. So that's one room of pigs that were vaccinated with a modified live PRRS vaccine, and then were challenged. Vaccine B is another room vaccinated with a different vaccine, as I mentioned, that were challenged with 144. The next room over is 144 all by itself, no vaccine. And then the next room over is pigs infected with 174, again, no vaccine. And you start to look at some of these numbers and you see there's a significantly better growth rate in the vaccinated groups, no difference between A or B, but both of those groups of pigs grew better than the non-vaccinated challenges. And look at the 144 non-vaccinates to the 174 non-vaccinates, no difference in average daily gain. Below that is percent mortality. You see 5.3% in vaccine A group, 4% in vaccine B group, 4% in 144 non-vaccinated group, and 13.3% in the 174 group. So trend towards significance there with more mortality in the 174 group. Let's look at fevers at day 14. We actually measured fever on multiple days. This is simply the kind of the peak, the heat of the battle. How hot are these pigs getting? And you see there lower temperatures, lower fevers in the vaccinated groups than the non-vaccinated groups. And then you can see the number of individual treatment events. These are injections. You can see numerically lower treatments in the vaccine groups versus the non-vaccinated groups. So some surprises there, and we can talk about this. Here, this is viral load. We wanted to see how much virus is being produced inside these pigs. So on the left, you've got days post-challenge, so day 3 down to day 35. We've got the different rooms, vaccine A, B, 144, and 174, just like before. And here we're actually measuring the amount of virus in the serum of the pigs. And I've highlighted day 14 to 21. That was kind of like when the fire was burning the hottest. And you start to see there's quite a bit of virus in these pigs. There's quite a bit less virus in the vaccinated pigs. And there's more virus in the 174 pigs. If you read all the way across there, you see 6.6 times 10 to the 7, say on day 14 in the 174 versus 4.6 at 10 to the 5 logs of virus in the 144 group. So we're starting to see some differences that the vaccines are actually doing a pretty good job, and there may be some differences in these wild types. 174 might be a little worse. These are the temperatures in some of the pigs that we measured on a regular basis. The top graph, these are the cedar pigs. So in this model, we took 10% of each room and we gave them the virus. And we measured their rectal temperature. And we let the virus spread through what we call the direct contacts. Those are the pen mates. And we measured their temperature too. So on top, you see the cedar pig rectal temperatures. Vaccine A is in blue. Vaccine B is orange. 144 non-vaccinates in gray, and 174 non-vaccinates in yellow. So you kind of see how the fever spikes at about day 7, it peaks, and then it starts to come down. Down below that are the direct contacts, same color lines for vaccine A in blue, vaccine B in orange, 144 in gray, and 174 in yellow. We didn't take these pigs all the way through. You see they're rising. They probably would have started to fall if we would have tested them further. But really, we kind of see all these fever responses very similar. Behavior score. This was a daily measurement we made in each of our rooms, measuring every pig's attitude and physical activity and respiratory rate. We gave them a score of 1 if it was an abnormal, or score of 0 if it was normal. So it's a lot of measuring each pig every day, and then getting an average, an average score for their behavior. So you see, again, days post-challenge on the x-axis, behavior score from 0 to 1, with 0 meaning non-affected, so normal behavior, and 1 meaning worst case scenario. A lot of respiration problems, very inactive pigs, real sick animals. And you start to see some differences here, again, between vaccine A and which was blue, vaccine B, which is orange. You see where those lines kind of meet and follow each other very closely. But then on the 144 in gray and the 174 in yellow, you start to see some separation. You start to see the 174 negative impact on the pigs to be actually numerically higher than the 144. We actually also recorded coughing. Again, Dale Polson, thanks to Dale, he brought in this SoundTalks device you see hanging there. Every time a pig would cough, it would be counted. And this light would change. If there was no coughing, it was green. If it was kind of medium level coughing, it was yellow. And if the place was really hacking, it would be red. And it allowed us to actually count the number of coughs and chart that over time. That's what you see in these two graphs. You see x-axis is days post-challenge, so time, and then y-axis is number of coughing counts. Challenge is that red bar, and the top graph you see is the two vaccines as compared to the 144. So you see the two vaccine groups, much lower coughing scores than the 144. Down below the graph is the 144 versus the 174. Again, both viruses causing quite a bit of problems, lots of coughing. And then we got to have some pneumonia. So this is a little bit of lung tissue looked at under the microscope. And if you've seen a normal lung, there's usually a lot of airspace, so a lot of white. The slide would be much more white. Here you've got a lot of pneumonia where the tissue is very consolidated. It's almost all purple and pink. That means the tissue is very inflamed. There's very little airspace, making it very difficult for the pigs to breathe. And so you see there on the left is an example of a 174 infected pig, and there on the right is a 1.4 infected pig. Very similar pneumonia scores between the two viruses. Biosecurity, what happened? And all those little trials we did, this is what we learned. Disinfectants, both disinfectants worked. After 60 minutes of contact, Ag Forte Pro and Synergize neutralized the 144, but the virus was alive after 30 minutes of contact. So these disinfectants take time. They need time to work. Contaminated feed was very easy, actually, to transmit the virus through feed. We put it in the feed, we let it sit for an hour, let the pigs eat it, and we showed transmission through feed. But when we mixed the mitigants into the feed, either the Guardian or the Salcurb, both of those mitigants prevented infection through contaminated feed. The transport model that we showed you, where we were backhauling complete feed in the simulation, that worked. I mean, the PRRS virus survived in that feed transport model, and that feed, that complete feed that was backhauled, so to speak, was infectious to pigs. And then survival in slurry, the virus lived for 14 days, but not for 21 days. And the shower in, shower out protocol worked very well. You know, when we went into a pen of infected pigs and did not take a shower, we could easily move the virus from pen to pen. We could find it on our boots and coveralls and hands. But if we took a shower, changed our clothes and boots, we did not transmit virus. Filters were very effective. We did find virus in the air, in the infected room space. You can see the numbers there, but not outside the filter. We did not detect any virus passing through the filter. So in this little model, the filters worked very well. So last slide before discussion. Under the conditions of this study, we felt that the virus that we used, the 174, wasn't worse than the 144 lineage 1C. This particular variant of 174 was more pathogenic. We felt that modified live vaccines were very effective against the virus, so we need to keep using them per label. We used a full dose and we waited 28 days per label before the pigs were challenged. So we have to use them at full dose. And these biosecurity protocols work. They work just fine. Aerosols and feed may be some risk factors for this virus, but as we showed you, the risk is reduced through filtration and feed mitigation. So basically what I want to say is don't give up. This is a highly pathogenic virus, no question, but we know how to deal with it. We've dealt with these PRRS viruses before. We have all the tools we need to be ready for this fall and getting into cold weather. We just have to keep up our spirits, follow the science, don't take shortcuts, and just keep with faith, because we can handle this virus coming into PRRS season. I have no question about that.